Okay, here we go. Section 2. So, as a reminder, section 1, we talked about average rates. Average rates, you need a change in our concentration, change in M over change in time. Time can vary, right? We talked about seconds, minutes, you can even go hours or days, or even stuff past that. Okay?
Can we do months and years?
You could. It's a little bit more difficult, but yes, you can. Then at the end of notes, we talked about our reaction diagrams. We talked about, okay, how much energy do you have to put in to that reaction to make those reactants start to go? We call that the activation energy, right? That hill or that hump it has to get over. But if it does, and it's at that peak, it enters into that activated complex. That's when you have the process of your reactants turning into products, okay? The other thing to be aware of is that particles to enhance or to talk about the speed have to have two things happen. One, pieces have to smack into each other, collision theory. They have to smack into each other hard enough with the correct orientation. And the last thing out of that graph that we talked about on section 1 notes was we have to look at their change in energy. If the reactants have higher energy than the products, exothermic energy is given off. If it's reversed, if those products are higher in energy, you have your endothermic or energy is gained in the process. Okay. Now, we don't have any math with section 2, but we talk about what could increase and or decrease the speed, the rate of a particular chemical reaction. So on the first slide here, we have 4 things that we'll talk about. 4 things: concentration, surface area, temperature, and a catalyst, or the presence of a catalyst here. Okay, so our first thing, concentration. If we increase the concentration, we increase the rate because we have a higher chance, a higher probability of our collisions. All right, so example I've used all day long. You guys are a little bit bigger class, but you still have some room to spread around and you don't always bump into one another. However, if I combine first period and third period and I pack this all into this class, more than likely you're going to run into one of those kids in that class because there's more people. More stuff, more chances of collision, more chances of getting that reaction going. Okay? Now, our example here in notes, it uses steel wool. I used to light the steel wool on fire. It doesn't always work out great though.
Can you do that for us?
We could try, yeah. So steel wool, if you put it in fire, it will basically light the little ends on fire. And the first picture shows it with just standard room air. It doesn't have a whole lot of oxygen. Now, this other flask is pure oxygen. More oxygen, more chance to get the fire going, aka more collisions. And so we have a faster or bigger flame ball. Yes?
Do you use a deep battery or just the light?
Oh, I use just a Bunsen burner because I didn't have batteries available. You can do it. I think there's been videos of people taking like aluminum foil and setting the steel wool on fire.
Yeah,
Probably
I
made
was
it fire.
photography, and we have to do this like
This one time,
Oh.
I did
So,
I said hand sanitizer on
Did
fire.
you use batteries?
well, you can like, he gave us examples.
That's what I was
Like, you would use a battery, like steel wool on fire, and have it up on the string.
That's true.
Petroleum together.
We like petroleum.
I made a fire at a steel wool one time. Fire? Yeah, but it's flammable if you get it hot enough.
I set hand sanitizer on fire.
Because they had petroleum.
And it, no,
Oh, it has alcohol in it.
Yeah, no, I turned all the lights were out and like the flame was like blue. The flame was blue.
I think it's
Because of the alcohol. All right, so second thing, surface area. You increase the surface area, you increase the speed, or you increase the rate. So let me ask you this. I have salt. I have one that is a cube of salt. The same amount I have crushed up salt. which would dissolve faster.
The card stops on.
Crushed up because it has more surface area. Again, more room to roam. So if I go back to this example and I say, hey, everyone needs to be consolidated around this desk, again, you're very restricted. So there's less chance of someone bumping into you, especially if you're in the center. Then I said, hey, spread out. So the more you spread out, the more surface area you have, the higher chances of a collision, which means that's going to speed that reaction up. So back to our steel wool. So steel wool, if you've never used it before, it comes in this package and it's really compact. Well, if you take that and you kind of spread it out, your oxygen can get in there, more room to roam, more room to interact. And so steel wool that's spread out is going to interact a lot faster. Okay, questions? Now, this is very important, and you guys notice it. Temperature will almost always be reported on these questions. Because if we increase the temperature, we're going to increase the rate. So, same chemical reaction, we can have it at room temperature, and then we increase the temperature to 100 degrees Celsius, a higher temperature, higher rate. And so we're going to have to report this is the rate at this specific temperature. The reason for this, higher temperatures, things are moving faster. Again, just like driving faster, you have more chance of getting into an accident. We have more chance of getting into a collision.
I've never been in a car.
Oh, that's good.
Well, I'm trying to.
All right, so then a catalyst. And I know for those either in bio or have completed bio, biology talks about this, okay? Presence of a catalyst. A catalyst is a substance that's going to increase the rate, make the rate go faster without being consumed in the reaction. So it does not show as a product. What it does specifically, best explained by this chart. The blue line here on this graph shows the reaction with the catalyst. It lowers the activation energy. Okay? Catalysts increase the rate by lowering the activation energy. Makes it a smaller hill to go over. Now, enzymes are a specific type of catalyst. They're a biological catalyst. Okay? Enzymes, it means they can only happen in biochemical reactions. So like stuff that happens in your body.
So if this happened in my body, this just happened in my body.
How
Yeah.
often does this happen in my body?
Every second, yeah.
Every second.
You wouldn't be alive without it. It would take too long to produce the energy.
I'm stopping there right now. I can feel it in my.
Yeah, wait,
I can feel it.
Okay, let me know how it feels in about 20 minutes.
So if this didn't happen for a second.
For
we'd be
1
dead.
second.
Not a second.
Like,
And there's like genetic
Oh,
things
somebody
where
join the.
there's genetic things where it causes things to slow down or speed up too much, right? If you have like a thyroid problem,
yeah.
you're getting too much interaction with that.
So if it speeds up, that's not good.
Yeah, you wanna be. Bio always says, hey, you wanna maintain homeostasis. You wanna be that
Homeostasis.
middle line where it says, I don't want to go too fast, produce too much, and or too little.
Is there
That's
like, could it be good if you do produce more though?
Like when you're running.
Yeah, like when you're exerting more, yes, but like under normal circumstances,
It's not
probably
really
a good
what
idea.
that-
And it should shift back down once your heart rate goes back down or whatever process you're doing.
Yeah.
It should quickly shift with that.
I'm so that I just turned it off.
So, like the production of glucose.
Yeah.
You guys, you guys
Just joking. I'm just joking.
Gosh.
Actually, I'm not because I didn't listen to what she said.
imagine that. All right, so here we go with an enzyme. So it's kind of cool. It has this lock and key method here. So this yellow item on the actual slide is the enzyme. It temporarily hooks in to whatever chemical. It goes through that reaction and then it goes away here. It's deflected off. The cool thing about it is that enzymes, well, catalysts can be used over and over and over again. And this makes that again, if we're talking specifically a biological process, really, really efficient and effective. Okay. Any questions?
No.
All right. So going through this, 2 types of catalysts: a heterogeneous and a homogeneous catalyst. Heterogeneous, the catalyst has a different state of matter than the reaction. So catalytic converters, the picture down here. Sure, you've heard of catalytic converters on your car,
Yeah.
catalytic converter thefts.
Were
It's becoming a
people
big
stealing them
thing.
last
Yeah,
year?
why do people steal?
Yeah, that's a good question. So the metal inside there is the catalyst. All right, it's a very high value metal, so
What
you
is
can
it?
sell or scrap the metal here.
So
It
it's like
should
melted
be
down.
a mix of platinum and rhodium.
So what? So you're saying is I should go to a junkyard and steal all the cattle?
Well, they usually take them off. Yeah, that's like one of the first things they do.
Especially like go out to the supermarket.
Yeah, it's right now. I should just go out
Yeah,
there right now.
but it's a felony. So do what your criminal
It's not
record
a
can.
felony if you don't get caught.
Right.
How much money is it though? Right, if yourself.
They can get like if you scrap it, like between $300 and $500, just depending on how big the vehicle is. To cut off, you guys see near exhaust, it's like a
Yeah.
box size area.
So if I cut off, so if I should kind of convert it from a semi, that's making me some money, that makes me some.
Probably, but the problem is going to be getting under it. So like a car, the reason they're doing the car
Because
theft
it's easy.
is you
Easier to
can
get under.
jack that up and then you can have that.
Yeah, exactly.
Can you wait until
How many
we announce
times? How many
those?
times have you been going home and you see like 60 semis just sitting right there?
All
Boom.
right, you let me know how you crank that thing up. Anyways, let's get through this. So, heterogeneous catalysts, platinum and rhodium. Those are really high value metals. That's why we got on that topic. The gas, right? You produce fumes. The gas, to try to reduce that impact on the environment, it interacts with that catalytic converter and it makes it somewhat safer or reduces the pollution out in the atmosphere. Homogeneous catalysts, they have the same physical state. Questions? All right, last thing here, an inhibitor is going to stop a reaction, okay? So food's a great example of why we use an inhibitor. Food will decay, right? We've all left something in the fridge too long and you see that rotting process start. So chemical or companies, food companies have gotten really smart, especially with stuff like apples and oranges. You'll see at the store, it's really, really shiny. The reason it's really shiny is because they put a coat, which is a preservative to inhibit the reaction from happening.
So what you're saying is I shouldn't, like, whenever I get a bag of apples, I shouldn't wash the whole bag off when I first get it. I should wait until I eat it and then instead of save the. Well, I don't know how to do it.
Why would you wash the bag? I'd probably wash the apple.
Well, the bag has holes in it.
Maybe. All right.
I don't do it.
Any questions? All right, I'm gonna post the homework. You have 28 minutes to do the homework.
What if it's not done by the end of the class?